Hello everyone, this is your mathematics educator Abhinav Jha, and I hope everyone is doing absolutely amazing and learning how to learn, right? Maths Unleashed. So great. So very nice to have all of you here on this our platform of Maths Unleashed. And today we will be discussing a very interesting concept, that is linear equation in two variables, right? A lot of students of foundation grades find it a little difficult to solve these questions, because there are two methods which predominantly we will be using. That is, one method is substitution and one method is elimination. So today we'll be doing fantastic questions which will be related to concepts like man work problems and upstream downstream problems of both. Okay, so fantastic questions coming your way. So let's proceed. And this is my brief credential. My name is Abhinav Jha, and I've done my B.Tech from NIT Nagpur. I have mentored already a rank 1, 40 and 79 in JEE Advanced year 22. I've also got more than 10 plus years of teaching experience in online as well. Okay, so let's start this amazing session of linear equations, how to solve it fast, right? So fast means you should be conceptually 100%, right? Your conceptual clarity of that particular question or concept should be up to the mark. Then only you can work on speed, right? Speed and accuracy comes when you have the conceptual backing. Okay, so try to bifurcate the question into 2 to 3 halves, right? And if you can do that, automatically you can work step by step, and then speed and accuracy can follow. Okay, so let's take up a very interesting problem. This is one of my favorite type of questions which I actually ask my students to solve. So 8 men and 12 women can complete a piece of work in 10 days, while 6 men and 8 women can finish the work in 14 days. Find the time taken by 1 man alone and 1 woman alone to finish the work. So we have two variables here. So we will assume that the time taken by 1 man to finish the work is, let's suppose, X days. Okay. The 1 man is able to finish the work in X days. So in 1 day, how much work will he do, right? So in 1 day, the man will be able to finish how much? 1 by X of the work, correct? 1 by X work would be completed. So in 1 day, 1 man can finish 1/x of the work, 1/x of the work. Similarly, if I go to the women, so let's suppose 1 woman can finish the work in Y days. So in 1 day, she can finish 1/y of the work, correct? This many work would be completed. So if I have 8 men, they will make the work 8 times, and 12 women will make the work 12 times, correct? So 8 men can finish in 1 day. How much work will they finish? 8 men. So according to my question, so I can say that 8 men and 12 women can finish how much work? 1 by X plus 1 by Y in 1. I have written this much work is going to 1 by X, and here we have to multiply, as this is 1 by X is for 1 man. So we have to multiply this with 8 and this with 12. So effectively 1 day work would be 8 by X plus 12 by Y. Now how would I equate that to? So see here, the first line is 8 men and 12 women can finish the work in 10 days. So in 1 day, how much will be they finishing, right? 1/10 of the work, right? So 8 men and 12 women can finish in 1 day how much? 1/10 of the work. Correct? They would be able to finish 1/10 of the work. So what will I get is, I will get that this 8 by x plus 12 by y would be equal to 1 by 10. Okay, that would be equal to 1 by 10. So that is my first equation. Similarly, from this we can get our second equation, 8 women, 6 men and 8 women. So 6 by x plus 8 by y equals 1 by 15. Fantastic. Okay. Now what we have to do is, we need to solve this. This is nothing but linear equation in two variables. What is this? Let me just write this in white text properly. So 8 by x plus 12 by y, 8 by x plus 12 upon y. Now what I'll do is, I'll multiply this equation with 2 and this equation with 3, so that I can make the coefficients of 1 by y same. So let's multiply this equation by 2 and this equation by 3. Okay, so what will I get? I will get 16 upon x plus 24 upon y is equal to 2 over 10, that would be 1 by 5, and this will become 6 into 3, which will be 18 over x plus 24 over y, that's what we wanted, and that would be equal to 3 by 14. I'll subtract both the equations. So this 2 would get cancelled. We'll get minus 2 by x is equal to 1 by 5 minus 3 by 14. Correct? Now we can take LCM. So my LCM would be 70 and this would be 14 minus 15. Fantastic. 14 minus 15 by 70. So I will get minus 2 over x equal to minus 1 by 70. So x will be equal to 140 days. So that means one man can finish a work, the whole work, in 140 days. Now I want the answer for y as well. So I will substitute in this equation. Let's substitute in the second one. So I'll get 8 over y is equal to 1 by 14 minus 6 over 140. Correct? 6 over 140. If I take 140 as the LCM, I will get here 10 minus 6, 8 over y. So this would be this will be what? Y will be equal to 140 times 2, because 4 and 8. So we will get here 280 days. So a woman would take 280 days, whereas a man took 140 days. So this is how we can actually frame the equations fast, and we can solve it by doing some calculations in our head also. This was quite a lengthy problem which will be obviously asked in 5 to 10 marks, right? Depending upon the severity of the question, because it can have many parts, right? Great. Let's go to the next type of problem. So how will I actually make you understand this concept of boat and stream problem is, let's suppose if we have here with us Usain Bolt. Okay, let's suppose I have Usain Bolt in front of me and he wants to run. Okay, Usain Bolt, let's suppose, runs at, let's suppose, 30 km per hour. Probably he might be faster, but if wind is flowing at 5 km per hour, huge wind, so what will be the effective speed of Usain Bolt? Effective speed of Usain Bolt in this case would be 35 kmph, right? But if Usain Bolt starts running the opposite way, let's suppose here 30 km per hour, so what will be the effective speed of Usain Bolt in this direction? Now the wind will stop him, so his effective speed would be 25 km per hour. So let's come back to the question. Now if you are going upstream, we are going upstream, guys. If we are going upstream, so water obviously flows downstream, right? So we have to find the speed of stream. So let's take it as y. Okay. We'll take this as y. Speed of stream will be taken as y. And let's suppose speed of boat in still water is x. So when we are going upstream, so this is our x and the water is flowing y. So effective speed would be x minus y. Whereas when we are going downstream, when we are flowing downstream, what's happening? The water will help us, correct? So speed of boat in still water will actually be held by the water. So effective speed in this case would be x plus y. Now it's a simple distance upon time and speed kind of formulas, right? So we have 30 kilometers upstream, we are going 30 kilometers upstream. That means 30 upon what will be the time it will take? So 30 kilometers divided by time divided by speed will give us time, right? Upstream speed is x minus y plus we're going 44 kilometers downstream. So 44 upon x plus y is 10, correct? So T1 plus T2 is equal to 10 hours for the first case. The second case, in 13 hours it can go 40 kilometers upstream, that is 40 upon x minus y plus 55 upon plus y equals 13. That's the question. Now we have to solve for x as well as y. We need x and y both. So how are we going to proceed? So I can make the coefficient of 1 over x minus y equal. So what I'll do is I'll multiply this equation with 4 and this equation with 3, correct? Absolutely, no doubt about it. So what will be 30 times 4? It would become 120 over x minus y, correct? It is very fascinating, isn't it? The question is absolutely amazing, and this kind of questions you will be getting in board examinations, Olympiads, you name it, right? IOQM, all of that, PRMO, RMO, NTSC, everywhere you will get these kind of questions which we are doing right now. So this will become, yes, 4 and 44 into 4 will become how much? 160 and 16, 176. 176 upon x plus y will be equal to 40. Now this equation will be multiplied with 3. So it will become 120 upon x minus y and plus 165. This would be what? 165 upon x plus y is equal to 39. Now when I subtract both the equations, so these two would get cancelled. I will get 176 minus 165, that would be 11. So it will be 11 upon x plus y is equal to 1 because we have subtracted 40 minus 39. So from there I'll get my first value, that is x plus y is 11, correct? Picture abhi baki hai mere dost. It has not yet, the question is not yet over. So we need x minus y as well. So if I put x plus y in this equation, let's suppose, so I'll get 30 upon x minus y plus 44 by 11, that is 4, is equal to 10. So I'll get 30 upon x minus y is equals to 6, correct? Yes. Now we will get from here, this will be as 5. So we will get x plus y is equal to 11 and x minus y is equals to 5, correct? Yes. I hope you are enjoying the session, right? And you can watch a lot of more videos as what we are doing right now. So you just have to like and subscribe, guys, because that will obviously give us a lot of motivation, and other friends of yours can also. Okay, so now if I just add both the equations, so what will I get? 2x equals to 16, that means x equals to 8. So we'll get x equals 8. I will put it here in this equation, I'll get y is equal to 3. That means speed of boat in still water is 8 kilometers per hour, that is 8 kmph, whereas speed of stream is 3 kilometer per hour. Understood? So I hope you guys enjoyed this question. It was a fantastic question, and so was the man and work problem. We'll be doing more such problems, guys, in the coming sessions. That will be incredible. Okay, so please like, share and subscribe to the channel for more such videos. Thank you.